We're all around electricity, pretty much 24/7, but, most of us don't really get how it's dangerous. So today, we're going to break down the real science of what happens when you get shocked.
Okay, let's get right into it. We've all seen those signs, right? Danger, high voltage. It seems pretty obvious. The more volts, the more dangerous the shock. But is it really that simple?
Well, the surprising answer? Nope. Not even close. In fact, thinking that high voltage is the big bad guy is one of the most common and, frankly, dangerous myths about electricity. The real story is way more fascinating, and knowing it could literally save your life.
So let's just totally tear this myth apart, shall we? We're going to see why focusing only on voltage gives people a really false and kind of deadly sense of security.
Just look at this. It's kind of crazy when you see it side by side. A taser can zap you with a whopping 50,000 volts, but it's specifically designed not to be lethal. Meanwhile, your plain old wall outlet, it's got a tiny 120 volts, but yeah, it can absolutely kill you. This right here is all the proof you need that voltage is not the main story.
So here it is, the key to this whole thing. It's not the electrical pressure, that's the volts, that's the real threat. It's the electrical flow, which we measure in amps. That is what makes a shock deadly.
All right, so if current is the real killer, let's talk about it. And you're probably going to be shocked, no pun intended, at how incredibly little it takes to cause serious harm.
At just 1 single milliamp, that's 1,000th of an amp, you can just start to feel it. It's not much more than a faint little tingle on your skin.
But you crank that up to just 20 milliamps, and things get really scary really fast. You lose control of your muscles. So if you grab onto something live, your hand clamps down on its own, and you literally cannot let go.
And here we are, the fatal line. At only 100 milliamps, the current is strong enough to throw your heart's rhythm into total chaos. It's a condition called ventricular fibrillation, and it's the point where a shock goes from being just painful to being deadly.
Now for the really sobering part. Remember that number, 100 milliamps to kill? Well, get this. Your standard, everyday wall socket can pump out over 15,000 milliamps. Let that sink in for a second. That's 150 times what it takes to stop your heart.
So, you might be wondering, if every outlet is that powerful, why isn't every accidental shock fatal? Well, the answer is because your body has one and only one natural line of defense, and that's resistance. We measure resistance in a unit called the ohm, but an easy way to think of it is just as your body's personal armor or insulation. The more resistance you have, the harder it is for that dangerous current to flow through you.
And most of that armor comes from your skin. As you can see here, when your skin is dry, it has a pretty high resistance, maybe 100,000 ohms. That's some decent protection. But get your skin wet, and man, that resistance just plummets, all the way down to around 1,000 ohms.
So here's the bottom line. Water basically demolishes your body's only shield. It makes you 100 times more conductive and 100 times more vulnerable to a fatal shock. This is exactly why you always hear warnings about electricity and water, like in kitchens and bathrooms.
Okay, but there's one last crucial piece to this puzzle. It's not just about how much current gets through you. The path it takes through your body is, quite literally, a matter of life and death.
So the absolute worst-case scenario? Hand to hand. Why? Because that path goes straight across your chest, right through your heart and your lungs. A path from your hand to your foot is also extremely dangerous. Now, a shock that just goes between your feet, you might get lucky because it can bypass those vital organs in your torso altogether. And this explains a classic electrician's trick you might have heard of. You'll see them working on live circuits with one hand tucked safely behind their back. That's not some weird habit, it's a deliberate survival technique to make sure they can't accidentally create that deadly hand-to-hand circuit. So to bring it all together, electrocution happens in a few main ways. The current can scramble your heart's rhythm, causing ventricular fibrillation. It can paralyze the muscles you need to breathe, essentially suffocating you. And it can generate so much heat that it causes horrific burns from the inside out. So now you know. It's not the big, scary voltage number you should be afraid of. It's a tiny, tiny amount of current. And that normal outlet in your wall has 150 times the lethal dose just waiting. Kind of changes things, doesn't it? I have to ask, will you ever look at a power outlet the same way again?